Hi, I'm Dr. Arthur Bradley from Disaster Preparer LLC, and today I'm going to talk about how you might protect your vehicle from an electromagnetic pulse. All right, so the first question we always want to answer when we take any kind of preparations is it worthwhile? Is this something we need to worry about? And the fundamental question in this case is, do vehicles need to be protected from an EMP? Now, if you'd asked me this question 6 months or a year ago, my answer would have been probably. There'd been some work done by the EMP Commission, but in my opinion, it wasn't very exhaustive and it didn't really draw clear conclusions. So I did a bit of testing of my own over the last several months, and I learned a number of things. What I basically did is I injected pulses onto my vehicle's electrical system, and I watched how those pulses propagated around the vehicle. What I found is that the energy propagates very efficiently around the cabling of the vehicle. And that makes sense because there's so many cables that are crisscrossed everywhere, and very few of them are shielded, and so that energy sort of couples between the cables and gets into all of the systems quite efficiently. Now, that combined with the fact that there's so much semiconductor electronics in our modern vehicles, and semiconductor electronics are very easy to damage with over voltages, all right? So those two things combined, I would change my answer from probably to absolutely. I think vehicles definitely could be affected and damaged by an electromagnetic pulse. Now, not all vehicles would be damaged, but I certainly think a large number could be. So if we take that answer to be true, that vehicles could be damaged, the next question might be, well, what is the specific danger from an EMP? What's it doing? And if you look at an EMP and you draw out its sort of three components of its waveform that gets generated, you end up with this very brief period pulse, this E1, might only occur in a period of nanoseconds, then a little bit broader pulse which might occur over microseconds, and then finally a portion of the pulse that might occur over seconds or even minutes. And each of those have different effects, all right? E1 can couple into everything, into all of the cabling, even into the small-scale electronics. Now, in my experience, it's always the cables that get you into the most trouble because the cables act as long antennas by which that energy couples in and builds up energy and flows into parts and so forth. So while it's true E1 is small enough it can directly affect electronics, in my opinion, the gravest threat is if it couples into the cables and then flows in on the cables. E2 in the microsecond range is really not short enough in time to affect freestanding electronics. It has to have cables attached again to bring in that energy like an antenna. And then E3 is so broad in time that it would need cables along the order of miles long to bring in any kind of sizable energy. And so in the case of a vehicle, of course, we don't have any cables that are miles long. So really E3 does not pose a danger to modern vehicles. All right, so we'll go ahead and cross that one off. So what we really have to worry about is E1 and E2, all right? And both of them could cause damage to a vehicle. Now, the good news is that vehicles already have some protection built into them. And that makes sense, right? We have nearby lightning strikes that occur. We get near very loud cell phone towers and other things that cause electromagnetic emissions to hit our vehicle. We don't want to upset the vehicle, blow a fuse, cause problems with the vehicle. So manufacturers have already installed some surge protection technology in vehicles, all right? So that's a good news. And it's specifically targeted against this E2 as well as against the pulses that the vehicle itself generates when you start or stop the car, turn on and off the AC, that sort of thing. And so E2 is partially addressed by the vehicle manufacturers. They've done some things to help protect the vehicle. Unfortunately, E1 is really so brief in time, it's not something that's normally built into a vehicle, so we would definitely have to worry about that, all right? So in order of worries, E1 is the most worrisome, E2 is certainly still a potential for damage, and we don't have to worry about E3. All right, so that's question 2. What's the danger of an EMP? The danger is that energy couples in, gets into the cabling, flows into the various subsystems. So question 3, why is it so hard to protect a vehicle? Well, I drew a little picture of a car. These are my wheels and my headlights here, all right? So I'm not an artist, but I tried to capture the general layout. And what we have here is a battery wired over to the fuse box that's under the hood. That might go off to the alternator, it might go off to the engine control unit, and that engine control unit might feed lots and lots of systems related to the engine, all right? So there's lots of things that come off this fuse box. I'm just trying to show the highlights of it here. It might also feed over to an internal fuse box that feeds things that are vehicle electronics, things like your dashboard or your radio, your auxiliary plugs, which is your cigarette lighter plugs, any kind of vehicle electronics, sensors, lights, things like that. And so there are 2 different fuse boxes in most vehicles nowadays, one under the dash typically and one under the hood. And all I'm trying to show is there's lots of different systems on modern vehicles, perhaps hundreds of different systems. And many of those have semiconductor electronics, they have microcontrollers, microprocessors in them. So there's a lot of points of susceptibility. And that's what makes it so hard to protect. There's so many different things that can be damaged, and they're all interconnected with these typically unshielded cables running all over the vehicle. So it's kind of like the worst possible case in terms of trying to protect them. All right, so the good news, as I mentioned, is that there is some protection already built in by car manufacturers. In particular, they're looking at current protection. Now, current protection means they're worried about, like, when you turn on and off something, a big slug of energy has to flow through the system, and that causes current to flow, and they don't want it to blow out fuses and cause problems. And so there are some surge protection techniques that they use in modern designs of cars to try and address some of those big surges of current. Not so much for over voltage protection, which is in fact what we're most worried about. We're not worried about big slugs of current going somewhere when we kick something off. We're worried about an energy wave hitting the vehicle and causing high voltages to develop at one end of a cable versus another, and that causes some current to flow. All right, so we're worried about this voltage protection, and that's not something that car manufacturers necessarily have addressed. So that leads us to the question is, well, what's the best way to protect a vehicle? Well, I've said for a couple years now, the best way I know to protect a vehicle is to cover it with conductive cloth. All right, now I stand by that answer. I don't know of a better way. It's the way many things are protected when they're really serious about it, is they put them in underground vaults or they cover them with conductive shelters. And that is a way that is a proven method of working, right? Essentially, you're just reducing the energy level that can get to the item. And it is still the best way, in my opinion, cover it with conductive cloth. Now, the problem with that, there's two problems. One is you can't drive with conductive cloth draped over your vehicle, all right? So that's a big problem. So that leaves your vehicle exposed a lot of the time. And number two is conductive cloth is very expensive, all right? It's expensive for me to buy, it's expensive for you to buy. So conductive cloth cover for a vehicle might range anywhere from $1,800 to $3,000, right? It's very expensive to make a giant cover of conductive cloth. So obviously we needed an alternate method. An alternate method which would allow us to drive our vehicle and still have some measure of protection, and that also wouldn't cost so much to protect the vehicle. So what I did is I created a plug that will go into your cigarette lighter plug, or what they call the auxiliary plug, and it's very high quality. It's got a unique transient suppressor inside of it, and I'll talk about its details in here in just a minute. But the idea of it is you insert these traps, these transient reducing auxiliary plugs, into every cigarette lighter plug that you can in your vehicle, and you get true multi-point protection, all right? So the idea of that is, yes, you've got an auxiliary plug here, so you're going to plug one in, and maybe you have a second auxiliary plug somewhere else in the vehicle, so you plug one in there. And on some vehicles, you might even have a third one, and you plug one in there. And this gives you multi-point protections to your electrical system. You also can attach a similar device that goes across the battery, all right? And I'll talk about that in a second too. So by doing that, you can end up with several places in your vehicle that all have this same type of transient protection across the power wires. So as the energy comes in and hits the vehicle, you don't know which direction it's coming from. All of those things work together to try and keep the voltage levels down across the vehicle's electrical system. So rather than relying on one giant component, let's say, to keep the vehicle's electrical system in check, we're going to distribute it into these small components to try and suppress all those over voltages. Now, the first thing people are going to say is, what? That thing is so small, how could you possibly suppress an EMP? Now, it's really important that you understand this one thing. The risk from an EMP to a vehicle is not a big slug of current that's going to come in. There's no path for that current. It's a voltage. It's an over voltage, which is like an electrical pressure, if you will. It tries to force current to flow, but it's really this pressure that develops on these wires that then causes those currents to flow. If we can suppress that pressure, that voltage, we can prevent the currents from flowing. So it's this high voltage that we have to worry about. And it ends up that to suppress voltage is very easy. You don't need lots of giant components. You don't need big, thick wire. You really just need very fast semiconductor electronics that can shunt that energy away before that electrical pressure or that voltage gets too high. All right? So in fact, these are plenty large enough, these components are plenty large enough to suppress that voltage. And it's the same type of technology that's used in other parts of a vehicle. All right? So yes, they're small, they go into the cigarette lighter plugs, and it's important that you understand that you're not trying to shunt away, 3,000 amps of current. what you're trying to do is to keep the voltage from rising to 3,000 volts. You're trying to keep it limited to a voltage level that the vehicle can tolerate without suffering damage. All right? So that's why you can get away with them being so small. All right, so that's this transient reducing auxiliary plug. One other thing to note about the T.R.A.P is it's a very simple product. All right? It's tempting as an engineer to always design very complicated things, multi-stage systems that are optimized for different things. And I've looked into that, and there's certainly some benefits to doing those kinds of designs. But the T.R.A.P is not that, all right? The T.R.A.P is a very simple, single-stage, extremely fast, high-power transient suppressor, all right? And as such, it's really not, quote-unquote, just an EMP device, all right? It's a device that's designed to suppress transients from any source, as long as it's fast enough to suppress them, which it is. It has a 1 picosecond turn-on time, and that it can draw enough of the energy away to suppress that transient. In this case, it can draw about 5,000 watts of very fast transient energy. All right, so it's important to understand that this product, this T.R.A.P, can be used for many other applications besides just EMP protection. If you had issues with transients in your vehicle from other things, you might try the T.R.A.P to see if it will suppress those transients enough to help protect your vehicle. Likewise, if you had a hybrid or electric vehicle, and maybe you're worried about transients coming in through that charging port, you might install the T.R.A.Ps in the vehicle to help suppress those transients that might come in through that charging port. All right, so again, the T.R.A.P is a general purpose, very high speed, very high power transient suppression device that just so happens to line up very well with the emissions that come from an EMP so that it can effectively suppress those as well. One thing I should mention is that many auxiliary plugs turn off when you turn off the car. Essentially, a relay opens and disconnects power from that auxiliary plug. And the reason they do that is so you don't accidentally leave something plugged into it that ends up draining your battery when the car's off. And so people might think, well, then the T.R.A.P would no longer be protective because it's disconnected from the circuit. But the thing of it is what we're trying to protect against is very high frequency energy. And these high frequency pulses that come in, they will jump right across those relay contacts. They will couple into the system regardless of whether or not that switch is closed. Now, I do think vehicles are less susceptible when they're powered off anyway, so that's good news. But even the susceptibility that it does have when it's powered off, the T.R.A.P device would help to mitigate by suppressing those high-frequency transients. Okay, let's go ahead and step away from the whiteboard and take a look at how the T.R.A.P actually works to suppress voltage transients. So I've set up a simple experiment where I took a pulse generator and I generate a pulse and drive it into an oscilloscope here so that you can see the pulse, right? So if I turn off the pulse generator, the pulse will go away, and if I turn it back on, the pulse will return. And what I've done also is I've taken an auxiliary receptacle and I've connected it across those same ports so that this would be like your cigarette lighter in your car, all right? And this would be an incident pulse. It could be from an EMP, could be from a nearby lightning strike, could be from some kind of surge that's inside your vehicle. It gets generated inside your vehicle. And I've got one of these T.R.A.Ps, these transient reducing auxiliary plugs, and I'm just going to plug it in this receptacle and watch what happens to the pulse. As soon as I plug it in, the pulse gets suppressed. Pop it back out, the pulse is back, put it back in, and the pulse gets suppressed. All right, so this shows just how effective this T.R.A.P plug really is. And again, the reason it works so well is it's got a transient suppression device that once the voltage gets too high, it turns on and it suppresses that voltage, all right? And that's very important to prevent damage to the electronics in your car. All right, so it's very effective, it's very simple, very easy to use. Just put it in your cigarette lighter plug and leave it there, and it will help to suppress transients from a variety of different sources. Now, one thing that was very important to Disaster Repair LLC is to make quality products, all right? I don't like buying junk. I would rather spend twice the amount of money on something and get a product that is high quality than I would to save a few bucks and get something that breaks after a few months, all right? The business is run the same way. We try and sell only the highest quality products. So that was job one, was to make sure we make a high quality product. The other thing was to make sure that the cost was reasonable, and I'll talk about that in a minute. So let's talk about the product first. So you'd think, well, a cigarette lighter plug, they're all the same. Well, they're not. We bought about 30 different cigarette lighter plugs, and what we found is that most of them are super cheap. They're made of cheap plastic. They have who knows what kind of metals on them. Everything about them was just cheap. You can buy them in bulk from China for $1 a piece or something, all right? And they're worth what you pay for them, in my opinion, right? They're not great quality products. They're not going to last long. They certainly were not suitable for a product like this. So we found a company in the US that makes really high quality cigarette lighter plugs. Now, they're not made for this application. We had to modify them, but it's a great product. It's the only one I could find that I was satisfied with. It has a Bakelite body, which you can tell right away when you hold it. It's not a normal plastic. Bakelite is the plastic they used to use back in, I guess it was the 70s, for like mixers and things like that. And what they found is that over the years, it weathered extremely well. It didn't age and crack and discolor the way a lot of modern plastics do. But it was more expensive to use, and so of course the industry's moved away from that. So this is still made with a Bakelite body. It has a phosphor bronze nickel-plated contacts here on the side, and you can tell they're really great quality. They have a heavy spring behind them so that it's going to stay latched into the receptacle. It has a gold-plated center contact here at the top, a spring gold-plated contact, and it has a built-in internal fuse. Right? So by itself, it was just a really great product. Now, inside of this, we installed a transient suppression component that's rated at 5,000 watts of transient energy that it can suppress. Right? That's a lot of power. And again, we're talking about power that occurs only in nanoseconds or microseconds. So it's a very high voltage that occurs for a very brief period of time. This part shunts it away. All right? So up to 5,000 watts for brief transients. Remarkably, its turn-on time is less than 1 picosecond. So it's not like a metal oxide varistor, which might take 10 nanoseconds or something to turn on. This is a different kind of component, and it can turn on in less than 1 picosecond. All right? And so that's remarkably fast, and it's plenty fast, about 1,000 times faster than we need, even for E1. All right? Now, certainly the cable will limit the energy flow around the vehicle, and all that has to be considered. But in my experiments, what I found is I could easily suppress those transients at multiple points in a vehicle because the part was so fast. All right? And finally, it's AEC Q101 qualified, which is just a standard that says that this part was tested to show that it would withstand the normal transients that a vehicle generates. Now, vehicle power systems are terribly noisy. Every time you start it, every time you turn on the radio, every time you kick on and off that air conditioner, the voltage jumps up and around and down. It can go up to 24 volts and stay there. It can go up to 100 volts briefly. It can drop negative even briefly. So it does a lot of bad things in your vehicle. Your voltage moves all around, but just for brief periods of time. And many components would be damaged by that. So I was careful. I paid more, of course, but to select a part that had been qualified to work in vehicles and withstand those transients. All right. So all that's been integrated into this package. I think it's a great product. I use it in my vehicle, and I just think it's a really high quality product. Now, let's address that cost thing. Now, it wouldn't do us any good to develop these if they're so expensive that people couldn't buy them. So the goal was to make the T.R.A.P less than $50. And we've done it. We were able to sell the T.R.A.Ps for $49, which I think is very reasonable considering the quality of the components and the amount of engineering that went into it. Now, in addition to the auxiliary plug T.R.A.P device, we wanted to come up with another product that went directly across the battery. So what we did is we took the protective device that's inside of the T.R.A.P and we integrated it into a weatherproof housing. All right, so the weatherproof housing has the exact same protective device as the auxiliary plug one. The only difference is we put it into a weatherproof housing and we wired in where we have automotive grade wire coming out the end, each going to its own ring terminal. All right, so this product attaches directly across the battery and it gives you one more point of protection in the vehicle. We're calling it the T.R.A.P B for battery. And again, the importance of it is the battery is one of the few places you have access to the electrical system, just like the auxiliary ports. And so we want to attach these protective devices to as many places as we can that we have access to. So by placing one of these across the battery and as many of the auxiliary T.R.A.Ps as you can, you end up with this true distributed multi-point protection that we're trying to achieve. Okay, so let's wrap it all up. How do I recommend that you protect a vehicle from an EMP? Well, it's really a three-step process. All right, the first step is to install as many of these distributed transient reducing auxiliary plugs as you can. If you have 2 auxiliary plugs in your vehicle, my recommendation is to put one of these in each of the plugs. If you have 3, use 3 of them. Again, what you're trying to do is provide that distributed multi-point protection suppressing those voltage transients. All right, that's step 1. Step 2 is to install some device. It doesn't have to be the T.R.A.P B, it could be another product, but install some type of transient suppression device that goes directly across the battery. Again, that's one more access point into the electrical system where we can suppress transients. Now, whatever product you use is fine. Just make sure that it will meet the demands of the vehicle. It will survive surges of the car normally starting and the air conditioner kicking on, all those sorts of things. And that it's very, very fast and can suppress both the E1 and the E2 type transients. All right, that's step 2. And step 3, which I consider sort of an optional step, is you can install high saturation ferrites on the cables that go from the battery over to the fuse box. All right. Now, the idea of that is those will limit the surges that are drawn out of the battery, all right? Now, they only do so for very high frequency surges, so they're not going to affect the vehicle's operation, but they would affect the transients that might be introduced by some kind of an external surge, all right? So you could put a high saturation ferrite on the positive lead and another one on the negative lead, all right? Those high saturation ferrites are available at disasterprepare.com. Regular ferrites won't really do the trick, and the reason is that there's a lot of current that flows through those wires, and ferrites end up saturating if you get too much current through them, unless they're these special high saturation ferrites. All right, so that would be step 3. Now, by doing those 3 things, what you've done is you've attacked the problem from a multi-point way. And to me, I've always found that works better. Oftentimes there's not a silver bullet that you can just shoot something with and everything is resolved. Instead, you sort of have to attack the problem from multiple angles, and that's what we're doing here. We're trying to put in multiple points around the vehicle that will suppress these induced transients, as well as any surges that might be pulled out of the battery. Doing that is the best method I know of overall trying to provide protection for the vehicle from something like an EMP, which is an external radiated threat. If you have any questions, feel free to jot them down below, or you can just go to disasterprepare.com, go to the contact button, and send me an email. I'll be glad to try and answer them.